Imagine asking your data warehouse a question in plain English and getting an answer in seconds. Imagine building complex data pipelines by simply describing what you want, no coding required. Imagine every person in your organization, from executives to frontline employees, having instant access to data insights. This isn't science fiction. This is happening right now with generative AI and AWS analytics services. Hello, and welcome to One Tech World. I'm Shruti Worlikar, Senior Manager of Analytics Specialist Essays at AWS. Joining me in this presentation is my colleague Anusha Challa, Senior Analytics Specialist Solutions Architect. Over the next 20 minutes or so, we'll show you how generative AI is fundamentally transforming data analytics on AWS. I'll cover a paradigm shift happening in analytics and introduce you to AWS's Model Context Protocol servers, the technology making conversational data engineering possible. Then Anusha will demonstrate how to leverage these capabilities with Amazon Bedrock and QuickSight to make AI powered analytics accessible to everyone in your organization. Let's start by understanding the fundamental shift happening in analytics today. For years, analytics has followed this same pattern: gather requirements, design schemas, write code, deploy pipelines, and finally analyze. This process takes weeks or even months. And by the time you get answers, questions have changed. Generative AI changes everything. Now we describe what we want in natural language. Pipelines are built automatically, and business intelligence becomes conversational. This isn't just about speed, it's about democratization. Analytics becomes accessible to everyone, not just technical experts. We are seeing organizations reduce time to insight from weeks to minutes. To understand where AI fits in, let's take a look at a typical analytics pipeline. Here's the standard flow. Data sources feed into ETL processes. Data lands in warehouses or lakes. We query and visualize it and finally deliver the dashboards. Notice the governance layers spanning the entire pipeline. Security, compliance, and data quality remain critical even as we add AI. This architecture is familiar to most of you. What's changing is how we interact with each stage. Now, here's where it gets exciting. Let's see where generative AI transforms each stage. Generative AI isn't just helping in one area, it's transforming the entire pipeline. Automating ETL processes. Imagine describing your data transformation in plain English and having the pipeline built automatically. Intelligent data mapping and classification. AI understands your data structure and relationships. Building semantic layers, business terminology automatically mapped to technical schemas. So everyone speaks the same language. Natural language querying, business users ask questions in plain English, no SQL required. Data visualization and BI, charts and dashboards generated from simple prompts. These capabilities fall into three main categories. One, MCP servers and AI powered IDEs for developers and data engineers. This is what I'll focus on in my section. Two, agentic AI plus knowledge bases for intelligent data discovery and accurate AI responses. And three, AI powered business intelligence for business users and analysts. This slide is our roadmap for the rest of the presentation. Let's dive into the technology making this possible. Model Context Protocol. Model Context Protocol, think about it as a USB-C port for AI. Just like USB-C, standardized device connections, MCP standardizes how AI applications connect to data systems. Before MCP, Every AI tool needed custom integrations for every data systems. If you had 5 AI tools and 10 data systems, that's 50 custom integration to build and maintain. That's not scalable. MCP is an open source standard from Anthropic, meaning no vendor lock in, and broad ecosystem support. The community is building connectors for hundreds of systems. LLMs can now interact with ETL tools, databases, data lakes, and external systems through a single standardized protocol using natural language. AWS has built 3 production ready MCP servers that connect to our core analytics services. Let me walk you through each one. Let's explore our first MCP server for data processing. This MCP server connects to 3 core AWS data processing services: AWS Glue for ETL, Amazon EMR for big data processing, and Amazon Athena for serverless SQL queries. First, create an ETL job. Describe your transformation in natural language. For example, convert JSON files to Parquet and partition by date. And the job is created automatically. Second, troubleshoot pipelines. Ask, why did my glue job fail last night? And get actionable insights and answers with specific error analysis. Third, optimizing performance. Request, how can I speed up my EMR cluster for this workload? And receive tuning recommendations. Fourth, cataloging data. Automatically discover and catalog data assets across your data lake. What used to take hours of coding and testing now takes minutes of conversation. Once data is processed, we query it efficiently. That's where our data warehousing MCP server comes in. This server connects directly to Amazon Redshift, our cloud data warehouse. Traditionally, business users submit requests to data teams, wait for SQL queries to be written, then wait for results. This takes days. Now they can query directly using natural language. For example, show me top 10 customers by revenue in Q4 and get instant results. Performance optimization, for example, why is this query slow? And get specific recommendations like adding sort keys or distribution styles. Data discovery and governance are equally critical. Our business catalog MCP server addresses this. This connects to Amazon Data Zone, our data governance and catalog service. As data grows, finding the right data and understanding what it means becomes harder. You end up with data swamps instead of data lakes. Create business glossaries. Automatically generate and maintain business team definitions that everyone in your organization can understand. Discover data assets. Ask, where is customer churn data? And find all relevant data sets across your organizations at your fingertips. Now, all of this is great in theory. Now, let's see it in action. Here is a demonstration of these MCP servers working together. Kiro is an agentic AI powered IDE that can connect to your databases, APIs, or tools. Using Kiro, you can develop projects, data pipelines, websites, apps, and more within minutes. There are other popular AI powered IDEs like Cloud Code, GitHub Copilot, similar to Kiro. In this demo, my goal is to create an ETL pipeline that creates a data set for further visualization utilizing the data processing and data warehousing MCP servers. Let's get started. First, we are going to create an empty folder and open it in Kiro. This creates a new project. To the project, you can add the required MCP servers. I can add these servers using a simple JSON configurations as you can see. Now that the MCP servers are added, I am ready to wipe code. I first ask Hero to understand my data in the S3 location. It nicely lists all the data sets, how many records are there, giving suggestion on the use cases required to power them. Kiro is using the tools available in the data processing MCP server to achieve all of this. I then ask Kiro to build an ETL pipeline to transform this data, generate matrix, and load the transform data to Redshift. The agentic AI workflows kicks in and performs a series of steps that eventually result in Glue ETL pipeline that loads data into Amazon Redshift within minutes, which would have taken weeks otherwise. So, we have seen how MCP servers transform the data engineering and processing side, making it faster, more accessible, and more efficient. But what about leveraging your organization's existing knowledge to make AI truly intelligent? And how do we make these insights accessible to everybody in organization, not just technical users? This is where Amazon Bedrock and QuickSight come in. With that, Anusha, over to you.
Thanks, Shruti. That was a great demonstration of how MCP servers revolutionize data engineering. Now let's talk about making AI truly intelligent by grounding it in your organization's data so the AI doesn't make mistakes by referring to world knowledge out there. Most of you would be aware of what generative AI models are. Amazon Bedrock is AWS's service that makes hundreds of generative AI models that are published by leading providers like Anthropic, Meta, Google, etc., available to you in a fully serverless mode. Each of these models have their own unique strengths. For example, Anthropic's Claude is known to be good with coding tasks. AI 21 Labs Jamba model is good with long context reasoning and so on. But these models alone have one critical limitation. They have the worldly knowledge, but do they know your organization data? No, they don't. So, what happens when you ask something that is specific to your organization? The model may say, hey, I don't know the answer, or worst yet, it may hallucinate. This is where knowledge bases solve the problem. Knowledge bases help in improving the accuracy of the responses that generative AI models generate. As intuitive as the name is, knowledge bases contain your organization's data. This data can be unstructured data like PDFs, Word files, so on and forth, or it can be structured data like the data that is stored in your data lakes, data warehouses, other databases. Let's look into each of these. First is unstructured data. This is typically large volume data. A variety of analyst estimates are showing that 80 to 90% of organizational data is unstructured data. Now, how do you store it and make it available for generative AI models to use when they're generating responses for your user questions? For that, you can use knowledge bases for unstructured data. In these knowledge bases, you store this data as vectors, which is nothing but an array of numbers that converts the text into numbers and store the unstructured information efficiently. When your user sends a prompt, the prompt is compared to the vectors that are stored in the knowledge base. The most relevant data is retrieved, and the documents are added to the prompt, sent to the large language model so that it is more knowledgeable about your data and returns the results in a more informative way. Next is structured or semi-structured data. Typically, structured data is stored in tables. To retrieve that information that's relevant to your user prompt, what should the generative AI model do? It should run SQL queries on the database and get the results. This whole process has a name. It's called Retrieval Augmented Generation or RAG. This is a picture that shows the flow for Retrieval Augmented Generation or RAGs. First, a user sends a prompt, something like, how many orders did we receive yesterday? This is not worldly knowledge. It needs your organization data to answer. So to answer accurately, the service, the generative AI service, first does retrieval from the knowledge base. So from the knowledge base, it understands that there are 500 orders that were placed yesterday. How did it understand it? It wrote a query, sent it to the knowledge base, got the required response, and understood that there are 500 orders. Then it augments the user prompts using the retrieved data. And the generative AI model generates a nice natural language response and returns back to the user. Imagine your data is in data warehouse or data lake and you want to perform natural language analytics. RAG with knowledge bases is a great solution for it. Let's see this in action with a small demo. Here we are on Amazon Bedrock screen. On the left, you can see there are knowledge bases. We'll go and access the knowledge bases and say, hey, create a structured data knowledge base. And here you see an option, Amazon Redshift, our data warehousing service is available there. You choose it. And then you choose which Amazon Redshift endpoint to use and what data sets should be available through this approach. You can add additional table and column definitions and then start testing the knowledge base. You can choose any model of your choice. Here I'm using Amazon's Nova Micro model and I start asking natural language questions. And I ask the question in natural language and you can see a response in simple plain English. What happened behind the scene? The knowledge base has generated a SQL query, sent it to Redshift, where it queried the relevant data, got the response back, and showing you an answer in simple plain English. This is how powerful RAG and knowledge bases are. They augment your user prompts with organizational data to improve the accuracy of the responses the generative AI models generate. We have seen how to perform analytics using natural language. How about reports? Business executives rely heavily on dashboards to make business intelligence decisions. Can we generate dashboards as well using natural language? Absolutely yes. Let's see how we can do it. AWS has a service called QuickSuite. It brings AI-powered business intelligence capabilities. To QuickSuite, adding data is simple. You can upload files, connect to databases, link to a data lake like S3, or connect to any of dozens of data sources QuickSuite automatically understands. It understands your data structures, it identifies relationships, and suggests visualizations. You can generate visuals by sending natural language prompts and get beautifully visual descriptions. Let's see this in a demo. Here I'm asking a natural language question. QuickSuite is going after the data sets that are made available to it, and it generates nice visuals that you can and add to stories, create dashboards out of them, and share them with your business users so they can make business decisions on top of this. You can see I can chat with this and it keeps track of history and I can keep refining the visuals that are being made using this feature. It's as simple as this to generate visuals using simple natural language prompts. Today, Shruti and I have shown you how generative AI is transforming every stage of analytics pipeline, from data processing to building data pipelines to generating visuals. Here are some key takeaways that we would like you to take with you. The first key takeaway, modern context protocol provides standardized AI integration for data tools. No more building custom integrations for every system. One protocol to connect to all your enterprise applications. Second key takeaway, Amazon Bedrock and knowledge bases improve accuracy of responses from generative AI models using RAG. Third key takeaway, you can build visuals using simple natural language prompts in Amazon QuickSuite. If any of you resonate with any of these that we have spoken today, let it be what Shruti spoke about or I spoke about. If it resonated with you and your organization goals, we are happy to chat further. Feel free to connect with us on LinkedIn. Our profiles are shown here. Thank you so much for joining us at the One Tech World Conference. We hope you found this valuable and we look forward to connecting with you. Thank you.